So, hello everyone. In this video, we are going to discuss about the unit number 3, that is embedded firmware. Firmware means it is a software. The firmware indicates embedded software. So, in this unit, we are discuss about what is embedded firmware, what is the reset circuit, what is a brownout protection circuit, what is an oscillator unit in the embedded system, what is the real-time clock usage of the embedded system, what is the timers used in the embedded system, and what is a watchdog timer. All these are the topics in the unit number 3, embedded firmware. So coming to the first one, what is an embedded firmware? So embedded firmware refers to the control algorithm and are the configuration settings that an embedded system developing dumps into the code program memory of the embedded system. So basically embedded firmware is refers to the control algorithm. So control unit, how the controlling part is done in the programming, total in programming, and the configuration settings to the embedded system developer dumps into the code. You have to write this firmware code and dump into the hardware. So dumping after the processing, the code is dumped into the hardware systems. What is the memory of the embedded system also most important. What is the space is available in that particular system is also most important. So there are various methods are available for the developing the embedded firmware. How to developing the softwares? Write the program in the high level languages like C, C++ using IDE. Write the programming in the high level languages like C, C++ to write the code and dump into the embedded system, embedded hardware. And write the program in the assembly language using the instructions supported by your applicant's target processor or a controller. So based on your type of processor and a controller, to select the you have to use the assembly language program ALP also to write the instructions based on the type of your controller and processor you are using, supported by instruction set. So basically the high level language is using C, C++, and IDE, or write a program assembly language using instructions supported by your application target, a processor or a controller. The instruction set for each processor family or a family of controller or processor is different, and the program written in either in the methods is given above should be converted into the processor understandable machine code before loading it into the program memory. So for the instruction set for controllers and the processors are totally different. So instruction set for microprocessor 8086 microprocessor instruction set is one model. The 8051 microcontroller instruction set is another model. You have to use ARM microprocessor is ARM advanced RISC machine ARM processor you are using. That instruction set is a different, and you have to use Raspberry Pi. That instruction set is a different. So each type of control, that is instruction set is different. That code you have to write in the instruction code in the format for the controller. It is a machine code before loading into the program memory. Converting into machine code is also most important. The processing of converting program written in the either high level language or a processor control specific assembly code, the machine readable binary code is called hexafile. Hexafile creation means before dumping into the processor or a controller kit for your embedded kit, whatever it language you have to write the code, either a high level language or low level language or assembly language. For before dumping into the microcontroller kit, it will converting into hexafile and then only it will be dumping. So before dump into your kit, that is converting into hexafile, so that is in the form of ones and zeros. These methods using for hexafile creation is different depending on the programming techniques used. So that is a creation of hexafile also uh, total different depending upon the program techniques you are using, means programming language you are using. In the program written in the embedded C or C++ using IDE, the cross compiler including in the IDE converting into cross corresponding processor controller understandable hexa file. So the program is written in the assembly language. You can utilize the supplies by the processor controller vendors to convert the source code into hexa file. So based on the language you are using, based on the programming language you are using in the how to write the code, so each language there is a separate compiler and separate conversion techniques you are using to converting the source code into hexa code. There is a system components refers to the ICs are necessary to the proper functioning of an embedded system. Some of the circuits may be essential for the proper functioning of the processor controller and the firmware execution also. In this one, these are the system components required for the some of the system components is required for essential for the proper functioning of a processor. Proper functioning means for the conditions, at any conditions it is required some extra system components are there in your system, your hardware kit or embedded design kit. So that is a watchdog timer, reset circuit, brownout protection circuit, and etc. These are the examples of circuits for ICs which are essential for the proper functioning of the processor and a controller. So in this regard, these are the system components required. So coming to the exa file creation and also this embedded C programming IDM cross compiler convert to the program into the hexa file. This programmed in the high level languages preferred each way. The high level language program is independent of the developer, easy to debug and consumes less amount of time for the development. Is very less time amount for the development. This program can be easily understand when including the comments and the document lines. Comments and the document lines. So coming to the assembly language one, so in this approach includes the writing of program in assembly language using the instructions supported by the processor. The processor provides the utilized to convert the source code into hexa file. This process is very long and the time consuming. So compared to the C++ language, I am assembly language programming source code conversion process is very long compared to this one. Since the program under the development must know the instruction set of the processor written to the program by the user itself. Hence, it will documented assembly code is difficult to understand to the user. So this is difficult to understand to the user. This is about embedded firmware. So embedded firmware in this topic, embedded firmware, you have to see embedded firmware. You discuss about the what are the languages supported by the our embedded system, how that code is written, after the code written, how the code is dumped into your hardware. So before you dump into the hardware, you have to converting into your source code into hexa file. So this is about the basic. This is a this is about the basic of embedded firmware.